Hello everyone, welcome to our channel. We are going to solve GATE 2011 question, and this is for manufacturing part. The first question: in a brazing process, the liquid metal fills the gap by which one of the following means? So guys, it is done using this capillary action, right? I think all of you know this, because in the brazing process there is a gap and we put the brazing material, and since it is in the liquid state, and because of this surface tension, it gets attached over here in the gap, right? And this action is called as capillary action. Okay, next: the nature of submerged arc welding flux with basicity index of 0.5. Basicity index is equal to 0.5. That means basically the basic oxides, the amount of basic oxide divided by acidic oxide, this is called basicity, and it is 0.5. That means the amount of basic oxide is less. So what is there? That means acidic oxides are more. That means it will be acidic, right? Next: which one of the following carbon equivalent in steel is considered good for weldability? See, weldability is defined. Suppose we do the welding process, then after welding, it should not form any kind of crack. Crack should not be there, right? This is what we require. So when there will be not any crack, if the carbon content will be low, because this carbon presence of more carbon makes it hard, right? So from this option, you can directly say it is 0.4, and practically the carbon equivalent, it is also called as should be less than 0.45 for a good welding, right? And guys, there is a difference between just carbon and carbon equivalent. Like the normal carbon, suppose in the element sorry, in the steel, suppose it is 0.2 weight%, but it contains some chromium, manganese, moly, these things. So these also have effects something similar to like carbon. Means carbon is increasing the strength. So similarly, chromium, manganese, moly can also increase the strength, and it increases. So that's why here the term comes as carbon equivalent. So it is like carbon equivalent equal to 0.2 plus Mn plus chromium by 6, something like this. You will see a formula like this. So this formula also keeps on changing depending on the different kind of alloy and the different condition, it changes. So that is what it is taken into consideration when we find this carbon equivalent. Okay, so this carbon equivalent will be greater than always equal to the carbon content in the metal, in the steel, right? Okay, next: assertion and reason type question is there. This is 2 marks question. During casting of aluminium, grain refinement can be achieved by addition of certain alloying elements. Yes, grain refinement can be achieved by adding certain alloying elements, like we add titanium. We can also add like niobium, but generally in aluminium we have seen it is titanium. The addition of the alloying elements may result in the formation of deoxidation products or intermetallic compounds, which may act as nucleation site for grain. Yes, this is 100% right, because this titanium which we add, so it is also added in the form of intermetallic like TiB2. So this TiB2 acts as a nucleation site. So similarly here some other elements if are there, there are other elements also, they form some oxides, they act as the nucleation site. Okay, so both are correct and R is the reason for it. Okay, so this will be the answer. Next: match. This is a match type question. Match those listed in group 1 with the additive methods listed in group 2. Okay, so first it is penetrometer. So penetrometer is used for which case? It is used in radiography to measure the depth up to which this radiography, the X-ray or gamma ray, can penetrate. Okay, differential coil probe. This differential coil probe is used in the case of acoustic emission test. And piezoelectric probe. So piezoelectric, because it forms ultrasound, it is used in ultrasonic test. Developer is used in this dye penetrant test. Okay, so options are 3, 4, then 1 and 2, right? 3, 4, then 1 and 2. So option A. Next, match the manufacturing process of group 1 to be used for producing the product in group 2. Okay, so let us see. First is drawing, okay, then forging, then rolling, then stretch forming, right? So drawing, so what are the things we make using drawing? But that means pulling, some kind of pulling. So it is basically tube which is made. Then forging, yes, for the forging we know it is the crankshaft, right? So crankshaft is made always by forging, right? Crankshaft looks like this. Means it is not the exact drawing, but somewhat like this. Plate, plate, how do we form? We form using rolling process, right? Then stretch forming, a large curved disc. So we form this large curved disc, means it is a disc. Suppose this is a normal disc, okay, this is a flat one, but if we want to make a curved one, so what happens, we put some kind of die and we put it over here and we stretch it. That's what it is called as stretch forming. Okay, so 2, 3, 4 and 1, 2, 3, 4 and 1. So option A. Next one, an aluminum billet of 300 mm diameter, okay, is extruded with an extrusion ratio of 16. What is the diameter of the final product, right? So for 48, let us find here. What do you mean by this extrusion ratio? It is area, and this area is the cross sectional area, right? Cross sectional area of initial billet to this cross sectional area of final billet. Okay, so it will be pi d square by 4. So d1 is d initial, pi df square by 4. Okay, fine. So pi by 4, pi by 4 we can cancel it. So it will be 300 square, and this df we don't know, right? And this is given which is equal to 16. So how can you find this df? So df will be 300, sorry, df will be 300 by 4, right? No issue. Okay, so it will be 150, so 75 will be the answer. Okay, for this question of 48. Now suppose we try to find for question of 49. I am solving over here only. Okay, what is the ideal extrusion pressure if the effective flow stress in compression is? Okay, so what is the extrusion process? So what is the pressure? So guys, we know this, that the extrusion pressure is equal to some constant K into ln R. R is the reduction ratio, or you can also call it as extrusion ratio. Okay, so this K is nothing but this flow stress value, right? This K is nothing but the flow stress value in the case of extrusion. Okay, when P we write it as pressure, right? Now suppose someone wants to find force, then we write it as force equal to K A naught. A naught means initial area into ln R. Okay, so this is different case. Okay, fine. So it will be K. So K is how much? It is 250 into ln 16. Okay. If you find this, then it will be 693.14 MPa. Okay, so this is the pressure we have got, and this matches with option A. Okay, and earlier it was matched with option B. Okay, guys, so thank you all. I will come up with some other videos of mechanical, physical, all within 1-2 days. Okay, so stay connected and best of luck for your examination.